Hello, space explorers. Today we're embarking on an extraordinary journey to one of the most intriguing and enigmatic moons in our solar system, Europa, a satellite of Jupiter. Recently, the scientific community has been abuzz with excitement due to a groundbreaking discovery that could significantly impact our search for extraterrestrial life. The detection of water vapor on Europa, an icy world that has long captivated the imagination of scientists, brings us one step closer to understanding whether life could exist beyond Earth. Europa is one of Jupiter's 79 known moons and is the smallest of its 4 Galilean moons, which also include Io, Ganymede, and Callisto. Despite its relatively small size, roughly 3,100 kilometers in diameter, making it slightly smaller than Earth's moon, Europa has become one of the primary targets in the search for life elsewhere in the solar system. This fascination stems from the fact that beneath its thick crust of ice, Europa is believed to harbor a global ocean of liquid water, possibly containing more water than all of Earth's oceans combined. The icy shell that covers Europa's surface is estimated to be between 15 to 25 kilometers thick, and beneath this layer, the subsurface ocean could be around 60 to 150 kilometers deep. This ocean is kept in a liquid state not by the heat from the sun — Europa is too far from the sun for that — but by the tidal forces exerted by Jupiter's immense gravity. As Europa orbits Jupiter, these tidal forces cause the moon to flex, generating heat through friction and preventing the ocean from freezing solid. Ever since the Voyager missions in the late 1970s provided the first close-up images of Europa's fractured and chaotic surface, scientists have speculated about the potential for life in its hidden ocean. The surface of Europa is relatively smooth, with few large craters, suggesting that the icy crust is geologically young and likely active. The most prominent features on Europa's surface are its long, linear cracks and ridges, which may have formed as the icy shell stretched and fractured, allowing subsurface water or slush to seep up and refreeze. In 2024, the James Webb Space Telescope, JWST, the most advanced and sensitive space telescope ever launched, provided new insights into Europa's enigmatic nature. By observing Europa in infrared wavelengths, JWST was able to detect and confirm the presence of water vapor escaping from the moon's surface. This discovery builds on previous observations made by the Hubble Space Telescope, which had hinted at plumes of water vapor erupting from Europa's icy crust, but the data from JWST provided much stronger and more detailed evidence. Water vapor was detected above specific regions of Europa, particularly in areas where the surface is known to be geologically active. These regions are likely sites where the ice crust is thinner or where cracks extend down to the subsurface ocean, allowing water to escape as vapor through fissures or geysers. The process driving these plumes is still a matter of scientific investigation, but it is believed to be similar to the cryovolcanism observed on Saturn's moon Enceladus, where water vapor, along with ice particles and organic compounds, is ejected into space from vents near the moon's south pole. One of the key implications of detecting water vapor on Europa is that it suggests active geological processes are taking place beneath the surface, potentially involving the interaction between the subsurface ocean and the rocky mantle of the moon. This interaction could create a variety of chemical reactions that might produce the necessary conditions for life, particularly if hydrothermal vents are present on the ocean floor. On Earth, hydrothermal vents host rich ecosystems fueled by chemosynthesis, where microbes convert chemicals like hydrogen sulfide into energy in the absence of sunlight. The detection of water vapor on Europa not only confirms the presence of an active subsurface ocean, but also raises exciting possibilities for the search for extraterrestrial life. If there are hydrothermal vents on the ocean floor of Europa, they could create environments similar to those found in Earth's deep oceans, where life thrives around these hot, mineral-rich vents. On Earth, these environments are home to a wide range of organisms, from bacteria and archaea to more complex life forms, such as tube worms, clams, and even fish, all of which have adapted to the extreme conditions found there. The potential for life on Europa hinges on several factors. First, the ocean must contain the necessary chemical ingredients for life, including water, carbon, nitrogen, phosphorus, and sulfur. Second, there must be a source of energy to drive metabolic processes. On Earth, sunlight is the primary energy source for most life forms. But in the dark depths of Europa's ocean, any life would likely rely on chemical energy produced by interactions between water and rocks, a process known as serpentinization, where minerals like olivine react with water to produce hydrogen and methane, potential fuel for microbial life. Additionally, the presence of organic molecules, which are the building blocks of life, would be a crucial indicator of habitability. Previous missions, such as the Galileo spacecraft, have detected hints of simple organic molecules on Europa's surface, possibly delivered by comets or formed through radiation-driven chemical processes. However, the discovery of more complex organics within the plumes or on the surface would significantly strengthen the case for potential habitability. While the presence of water, energy, and organic molecules are promising signs, it is important to note that the existence of life on Europa remains speculative. Life as we know it on Earth requires not just the right ingredients, but also time, millions or even billions of years, for complex organisms to evolve from simpler forms. Whether Europa's ocean has remained stable and suitable for life over such timescales is one of the many questions that future missions will seek to answer. The detection of water vapor on Europa has intensified interest in future missions aimed at exploring this intriguing moon in greater detail. NASA's Europa Clipper mission, set to launch in 2025, is at the forefront of these efforts. This mission will conduct detailed reconnaissance of Europa's ice shell and subsurface ocean, with the goal of understanding the moon's habitability and preparing for potential future lander missions. Europa Clipper will carry a suite of scientific instruments designed to study Europa's ice shell, subsurface ocean, surface composition, and geology. These instruments include ice-penetrating radar to determine the thickness of the ice and to search for subsurface lakes, a magnetometer to measure the magnetic field and infer the depth and salinity of the ocean, and spectrometers to analyze the surface and atmosphere for signs of organic molecules and other chemicals. One of the mission's key objectives is to investigate the plumes of water vapor detected by JWST and Hubble. Europa Clipper will fly through these plumes if possible, directly sampling the ejected material to analyze its composition and search for signs of life. This direct sampling could provide unprecedented insights into the chemistry of Europa's ocean and the potential for habitability. In addition to Europa Clipper, there are proposals for future missions that could land on Europa's surface and even penetrate the ice to explore the subsurface ocean directly. Such missions face significant technical challenges, given the extreme cold, radiation, and the thick ice covering the ocean. However, the potential scientific rewards are enormous. If we could deploy a lander equipped with a drill or a cryobot capable of melting through the ice, we might be able to explore the ocean itself, searching for microbial life or other biosignatures directly. Moreover, international collaborations could play a crucial role in these explorations. The European Space Agency, ESA, is also planning the Jupiter Icy Moons Explorer, JUICE mission, which, although primarily focused on Ganymede, will conduct flybys of Europa and Callisto, providing additional data that could complement the findings of Europa Clipper. Europa stands as one of the most promising candidates in our quest to find life beyond Earth. So, as we continue this journey of discovery, keep your eyes on the stars and stay tuned for more updates from the frontiers of science. The search for life is far from over, and Europa might just be the key to unlocking the secrets of the universe. Until next time.